A physician wants to develop a criteria for determining whether a patient's pulse rate is atypical, and she wants to determine whether there are significant differences between males and females. Use the sample rates below. So we have sample male pulse rates for 10 men and sample female pulse rates for 10 females. Construct a 95% confidence interval for the mean pulse rate for males, round to 2 decimal places. We will use the male data to construct part A, and part B for females, we're going to do the same thing. We're going to use the female data for part B, and then we're going to answer the question, is it possible that the population mean pulse rate for males and females is the same? So this is very similar to your online homework, so you could follow these examples for how to approach your online homework. Your answers are going to be different online, but you can use the same approach for solving the problem. So the first thing you want to do is realize that this problem doesn't provide you with a population standard deviation. It doesn't even provide you directly with a sample standard deviation. It gives you sample information in the form of raw data. So because of that, you don't have the population standard deviation, but you do have access to the sample standard deviation, and so you will be using the t-distribution to solve this problem. So for males, the formula that we're going to use is going to involve the t-distribution, and we're going to be using a sample size of 10, and we're going to use a t-score of t sub 97.5. So are we using the normal distribution or the t-distribution? Just for the reason that I stated earlier, you don't have access to the population standard deviation, but you can calculate the sample standard deviation, and so you will use the t-distribution. To get the sample mean for the formula and the sample standard deviation, that both of these things need to go in the formula, you don't have that, so the ideal thing to do is to figure out what they are, and since you have the raw data, you're going to use your calculator to put these two sets of data into lists and calculate the mean and sample standard deviation. Okay, so you're going to go to your calculator, put the data into 2 separate lists, run one var stats on each list, and from that you will get the sample mean, the sample standard deviation, and using that sample standard deviation you divide by square root of n to get the standard error. So there's the sample mean, but let's go right to our calculator. I'll show you how to do this. I put the data in already, but if you want, pause the video now and put in the male data in L1 and the female data in L2, and you should have 10 rows for each of them. And when you're done, come to Stat, Calc, one var stats. Remember that you're using the first list for men. Your sample mean is 74. Your sample standard deviation is 13.0979. 13.0979. So here's our data for the men, 74 and 13.0979. We're going to complete the male confidence interval first, and then we'll come back and we'll do the female confidence interval. So plugging in that X bar that we just found to be 74 and the sample standard deviation, 13.0979, we are going to put those numbers into our formula. And but first we have to go to our calculator to figure out what the t-score should be for t 97.5% with a df of 9, 1 minus the sample size. So come to your calculator, second DISTR, IMVT, 0.975, DF of 9, we did this earlier, this exact sample size. So it is 2.26. 2.26. And so we can plug that 2.26 into our formula. And here we go. So there's our formula ready to get calculated with its values plugged in. And when you do that into your calculator, you're going to get 64.64 to 83.36. And I will do that with you now. Let's do 74 minus 13.0979 multiplied, that is not correct, sorry. 74 minus the t-score, 2.26, multiplied by the standard deviation, 13.0979, divided by the square root of n, 10. Okay. I'll scroll back just to make sure you have the same thing on your calculator screen. Okay, and hit enter. 64.64, rounding up because there's a 9 there. And then the upper limit of the confidence interval, 83.36. To interpret this, we state that we are 95% confident that the true population mean pulse rate for males is from 64.64 to 83.36. Okay, so we are going to leave it at that for males, and then we're going to jump over to the female data and calculate the same confidence interval for the females using the female sample data. So putting the female sample data into your calculator, I have mine in L2. We're going to do the same thing, and we are going to calculate the statistics for the females. Sample mean is 94.8. Sample standard deviation is 14.7332. Okay, so 14.7332. Okay, 94.8 and 14.7332. Now it's the same t-score. It's the same 2.26 because it's the same sample size. It's n equals 10, so df equals 9, and the same confidence level, 95%. So for a 95% confidence interval, we're using the t-score labeled 97.5%, and using INVT, we did this already, we get a 2.26 for this t-score. Plugging in the rest of the values for x bar and s and n, we have this, okay, 94.8 minus 2.26 times 14.7332 divided by the square root of n, and then we have the same thing on the upper side with an addition instead. So let's try that together with the calculator. 94.8 minus 2.26 multiplied by 14.7332 divided by the square root of 10. 84.27, and I believe we're going to keep it rounded to 2 decimal places. We do this again and we change that minus to a plus. Same formula, but just an addition instead of a subtraction. and we have the upper end, 105.33. Okay, 84.27 to 105.33. And to interpret this, we state that we are 95% confident that the true population mean pulse rate for females is from 84.27 to 105.33. So now we have the pulse rates for men and the pulse rates for females. These are estimates of the population mean. And if we graphically look at them together, there's males in blue, females in pink. This is the male confidence interval from 64.64 to 83.36, and the female confidence interval from 84.27 to 105.33. Remember, these are estimates for the population mean, and these are estimates built with 95% certainty. So we're 95% certain that the male population mean pulse rate will be somewhere within the blue arrow, and we're 95% certain that the female population mean pulse rate will be somewhere within the pink arrow. And then we're asked this final question: using these results, is it possible that the population mean pulse rates for males and females is the same? Well, if we look at the upper end of the male confidence interval and the lower end of the female confidence interval, there is a numerical gap between 83.36 and 84.27. And because there is a gap there and there's no overlap, the answer to this question is going to be no. It's not possible that they are the same. And this is based on our 95% confidence intervals. Since the confidence intervals for male and female pulse rates do not overlap, the population mean pulse rates cannot be the same. The female population pulse rate must be greater than the male population pulse rate. We know this with 95% certainty. Now, you may not get results like this when you do your homework. Perhaps when you do your homework, I'm just going to give you a visual of what could happen. Perhaps you will have two confidence intervals that do overlap. And if they do overlap, then it is possible that they share a population mean and that they could technically have the same population mean somewhere right here. But that's not what happened in this particular problem with these particular sample numbers. So let me go back. So keep that in mind when you do your homework. Here, the answer to the question would be no, but if the numbers or if the arrows did overlap and there was an overlap of numbers, then the answer would have been yes. They could possibly have the same population mean. So when you do confidence interval questions, you are going to be faced with a question of whether or not it's a problem involving z-scores or a problem involving t-scores. If the problem gives you a standard deviation for the population, then you are going to be using z-scores. And the z-scores that you should memorize or put on a note sheet are 1.65 for a 90% confidence interval, 1.96 for a 95% confidence interval, and 2.58 for a 99% confidence interval. If the problem does not give you a population standard deviation, if it gives you a sample standard deviation, then you use t-scores. And this is a little outdated. Let me just fix this. When the problem gives you t-scores, you use INVT to solve that problem and get the t-score and plug that t-score into the formula. Now, if a problem provides you raw data, like the last one we did with the pulse rates, then you are going to make sure that you use t-scores because you're going to use the raw data to find the sample standard deviation of each data set.